Welcome back, friends. So in today's video we are going to work on project number 3, house prediction using XGB regression. So before proceeding, we will understand what is regression and what actually XGB regression is. So as we did in earlier projects, we use classification techniques in machine learning to classify the data attributes. But in today's video, we will use regression. We use regression when we have to predict a value. Like in this project, we will predicting the value of house. So in these types of cases, we will use regression. Now, so it's a NVIDIA article about XGB regression. You can also check it out. It's a good article. So in this XGB regression, what we did is we build a decision tree, and each decision tree gets a estimate value, what the value would be. Like suppose this tree 1 gives the value v1, and decision tree gives the value v2, and decision tree number 3 gives the value v3. Then we will find the average of all these value, and that will be our final answer. As it says, decision tree creates a model that predicts the label by evaluating a tree of if-else, true-false features questions. Like as the example is given here, suppose suppose it is a decision tree. If the size of the room is more than 2000 square feet, then we will have two options, yes or no, true or false. If the number of bedrooms are greater than 3, true or false. If the number of bathrooms are greater than 3, true or false. Likewise, so it will estimate the values as you can see here. Suppose it's a decision tree 1. For decision tree 2, the level of attributes would be changed. Suppose if in level 1, if the number of bedrooms are interchanged with the level 0, so it would give the different value. Okay, so this will tell us all the different values, and then we will take the average. We can also use it in a classification problem, but in most of the cases it is used in regression problems. Okay, so it's all about the regression. It is a quick guide. You can refer to this article. It is a good article. Okay, so we'll getting back to our project. So we will be using Boston housing dataset. I will be pasting link in the description, and as you can see there are 14 properties or 14 columns. If you want to know about more about this dataset, you can just read all these things what it says. Let's get back to our project, and I have already uploaded the Boston housing dataset. You can just click on the download button and import using this option, upload to session storage. Now first I will import numpy as np, import pandas as pd, import matplot library dot pyplot as plt. Now I will from sklearn dot split. I don't want these things. Okay, so then I will import matrix from xgb boost. I will import xgb classifier It should be regressor. I didn't. Regressor. Okay. So let me explain all these things. The first one is the NumPy. NumPy is used to create arrays, and NumPy arrays are more efficient and resourceful than normal arrays. Then we have pandas. Pandas are used to put our data set into pandas data frame, or you can say tables. Then we have matplot library that is used to draw graphs and histograms, uh, line charts, etc. Then we have cbond that is also used to draw graph, but I will explain you when we will use it. Then we have train test split that is used to split the data into predefined proportion. Let's say we have to divide a record of 100 records into 2080, so it will help us to split. The first one will be used to train the data model, then the second label will be used to test the model. Then we have matrices. So matrices is used to test the accuracy of our model. So when we have to find the values in regression, we use mean square method to find the what is the actual difference, what is the how accurate our model is. And then we have XGB regressor that will be used to train our model. Then first we will import our import dataset. It says house price dataset is equals to pd dot read csv. Read csv, it says something as house Boston house, yeah, Boston housing dot csv. Then we will print first 5 rows, house price dataset dot head. So it will print the first 5 rows of the head. If you want to print 10 rows, so just you can write 10 and it will print 10 rows. Okay, for now I will just print 5 rows. Then we will print number of rows and columns. Shape, so it will give us how many rows are there and how many columns are there. Then we will check for null values. We dot is not correct, so we don't have any null values. Now we will print statistical measures dot describe. As you can see, we don't have any null values, or 506 are the number of rows and each of the column has all the rows. Then we have mean. Then we have 25% means that 25% of the value are less than 0.08 and 50% of the value are less than 0.25, and same goes with 75%, that 3.67%, 75% of the values are less than 3.67. okay, now we will use correlation. Before that we will understand what correlation is. So there are two types of correlation. The first one is the positive correlation. The second one is negative correlation. Okay, so what it says, let me explain. Suppose if the area of the house increases, so it is directly proportional to the price. If the area of the house increases, and so the price, so they are directly correlated, they are proportionate to each other. So it is a positive correlation in which both the entities increases in with some proportion. Okay? Then we have negative correlation. It says that if one entity is increasing, the other entity will decrease. This is the negative correlation. So to find the correlation, we will use house dataset dot co correlation. Then we'll print correlation. So you can see that crim is a proportion to crim because they both have the same values. As you can see, all the values which are diagonal will have 1 because they are correlated to each other. Okay, if we see that Zn is negatively correlated to crim, likewise you can say age is positively correlated to crim. If age increases, crim also increases. By what proportion? 0.35. So now we will construct heat map. So what heat map is, let me just show first. Plot.fixed size, yeah, I think it's correct. Heat map dot correlation, c bar is true, square true, and mft and not true, that's good. Map blues, okay, it's correct. So let me explain the code first. So plt.figure means that we will create heat map of 10 by 10, and then sns.heatmap, we will pass first, we will first pass the data. Then we have c bar, this is called the c bar on the right hand side. Then we have squares, as you can see these are all squares. fmt means point up to how many digits. Let's say if I use 0.2f, so it will give me up to 2 decimals. Likewise, a not kws size 8 means all the sizes you can see here is of 8. If I type here 10, the size of the text will increase. And blue means you can see the color is blue. Okay, then you can visualize that all the entities in the diagonals are equally correlated, and you can see tax and radius, they are 0.9 correlated, they are highly correlated. Same goes with grade and tax, they are 0.9. You can see age and z, and they are negatively correlated. Likewise, you can analyze the data. Now we will split our data. Splitting the data into target and labels. So what is MEDV? Is the target variable, that is the price. What is the, yeah, here you have MEDV is the price. Yeah, 24, 21, 24. It must be in $1,000,000. You can see here it says what it says. You can see I have just saw that it says column MEDV, MEDV, MEDV. Let me just print all the columns first. The full form is millions. median value it's 1000, so multiply all the values by 1000, you get the h value 24,000. Likewise that. Okay, now we have splitted our data. Now we will split the data into training and test data. X train, X test, Y train. We are using 20%, that's correct. Now we will print x dot shape, x train dot shape, x test dot shape. So as you can see, originally we had 506 rows, and after splitting we have 404 rows in train data and 102 rows in test data. Now we will train our model training using XGB regression. So when model is equals to, we will load our model XGB regressor, then we will train our model training model dot fit x train y train, that's correct. Then we will, so the model has been trained. Now we'll predict the model predicting the training data. Okay, so we will use train data predict model predict, that's correct. Then we will print training data prediction. So it has predicted all the values. So we have 404 values, so it has printed all the 404 values. Now we have to check all the values. Okay, so just let me use mean square, or you can say R square error method. So why we use R square error? Because you can see all these are in decimals, and we have to check whether 23.121 is how far, you can say how far it is from the original value. So to predict it, we use R square method. Suppose in original we have let's see how much it is 23. Okay, suppose it is 23, so it is more so our model has predicted 0.112 more than the original value. So the difference between them will give our accuracy score. So here we use R square error method. This is score 1 matrices matrix dot R to score R square score, yep, pattern predict, yeah. And then we will print mean absolute error, score 2 matrix dot mean absolute error pattern. So as you can see, we our model is 99.99% correct, and we have very little error, that is 0.00913. That's really good. Now we will visualize our model. Visualizing the actual prices in graph. So plt.scatter by train and training data. I think it was your prediction. X label is actual price. Yeah, it's okay. Yes, it's correct. So it's just it's a simple syntax. We are using X train and train data prediction in x-axis and y-axis, and we are labeling all the x-axis and y-axis, and uh, title is also there. Then we have shown the graph. As you can see, it's a straight line, so our model is correct. It's kind of pretty correct. Good. Then we will prediction on test data, prediction on test data, and test data prediction predict. Yeah, it's correct. Now we will find out r square error and mean square error. It will use same. We will just test and test training data, test data, so our model is on test data is 90% correct, and it has an error of 2.07%. That is good. Any model with 70% accuracy score is good. If you want to visualize on the graph, you can use same techniques. Just replace it. You have to write test here because we are testing test data, and in place of training we will use an actual price predicting plus actual price. So you can see here the plot. So our model is pretty nice. So that's all for now. If you have any query, just let me know in the comments. Thank you.